Okay.
I meant to comment on that.
Yeah, GRA had a lot of more introduction about why farmland recharge is important, how it fits in, the broader picture, and not just GRAT.
Yeah. Because you started with the Tulare Lake, and I meant to comment to you that that was different than what I'd seen before, but I didn't like it.
Do you think that, do you want to be able to talk more broadly like that? Because I mean, that's kind of, that one starts broadly, then comes into the same place in terms of the GRAT. You know, I'm thinking, I mean, when Joe presents, he does a combination of those sort of intro slides, which might be closer to the TID. Let me see. Let's see, GRAT. Yeah, that's right. Yeah, okay, this one's kind of does the abbreviated version of that. Let me do this one.
Okay.
And share screen. Okay. Let's see if this. Yeah, so the good thing about this presentation actually has talking points as well at the bottom of it, so I can send this to you.
Okay.
I wonder if it would be good actually to send it to you. I don't know if you want to take notes on the slides, see, or if you want to just record it now and then come back in and you can add your own talking points to it.
Yeah, I think I'll listen and then I'll go back and add.
Okay. All right. So you can record. Yeah, you'll record from your end there, or it is already.
Yeah.
Okay. So yeah, so this is really diving into immediately into GRAT and introducing the two organizations. And you know, do you already have your talking line down for how you talk about sustainable conservation? Have you worked on that, or do you have our messaging documents?
Yeah, it's interesting because you and Ashley very much talk about the economic side of it, so it's a little bit different than what I've heard from other people.
Really, that's interesting. I should send you. Make sure, you know, if you go to the. I'm not sure if it's on the communications site or not, but it's the. We have this whole page on messaging that came out before you joined the organization.
Yeah.
And the official 1-minute message, you know, is what I pretty much use and what Ashley uses, and that's what all employees are supposed to use some variation of. Okay. So let me follow up with you on, take a note on that to send that to you. Okay. Back to here. So, you know, that sustainable conservation's message, which this is the short version I always use, is that we're working together with diverse groups to find solutions to natural resource problems that make economic sense. And we always put that economic sense piece in there. It's, you know, we used to be an environmental organization and wanted to distinguish ourselves as an organization that solves, you know, resource environmental problems, but in ways that make economic sense, because that's what makes us sustainable. Right? You make our work sustainable. You know, I spent way too many years trying to subsidize farmers to do things that didn't make economic sense to them, and it just doesn't last. They don't keep doing it. It doesn't make economic sense. And then Earth Genome being an environmental data analytic organization, and they use big environmental data to support planning and decision making, and also the bottom line, so economics again. So, oops. I think we'll get into GRAT as I proceed. There's some language here. So we talk about, Don Cameron as being sort of the origin of this idea. One of the key things I always like to talk about sustainable conservation is that we find solutions that work at the ground level. We don't propose policy unless we can find solutions that make sense to decision makers. And so Don Cameron's a great example of someone who is already doing this work. We helped evaluate that, build on that, and promote it at the regional and statewide scale. Another key theme that I always talk about more elaborate in the GRA conversation was that the rivers used to spread out and across the floodplain before we contained them in our levees. And we've lost that recharge function by protecting our lands from flooding. And there's a way, really what we're doing with recharge is allowing that flooding to come back onto the landscape in a controlled way, the right place, the right time, and the right amount, which were key terms we got out of the grower survey we did in the McMullen area. And those were really key things that farmers said if they do it, if they had control over those three things. So again, it's listening to what the locals say, building up from there.
What were the three things? Timing,
they'll do recharge. Yeah, if they can control timing, where, so when and where and how much. They'll take extra water, but only if they have control. They don't want to be told it's June 1st, you have to take this water on all your lands. It's obviously not going to work for them. So we're bringing the floodplain, we're bringing the river back to its floodplain through engineered structures. It doesn't look like just rampant flooding. It's very controlled. And so we've been sharing that message for now 7 years. Change that to document what the system does and present the results to other farmers, to water managers, and policymakers. There's the need to evaluate this in the field, as you well know, all the demonstration sites, monitoring. We do this to get a record both of how much water can be recharged and then link that to the crop effects of the farmer, at the farmer's perceptions of that. UC Davis does this at a much more detailed quantitative assessment of the crop effects, but we tend to rely on what the farmer tells us about whether they perceive it to be an issue or not, and they're agronomists. And that's a point I always like to emphasize. UC Davis is going to get a lot more information than we can capture with our method. But the fact is farmers are already doing this, and they're making the calculated decision that this is worth doing, and they're starting to push the limits of that, beyond what academic research has been able to show is safe yet. But the evidence from their experience has been that it hasn't caused harm, and that's largely because the soil never really gets saturated. That we're doing this on very sandy soils that have rapid infiltration, and that there's still oxygen there in the soil for the tree roots to survive on. And stop me at any point you want to clarify or understand more on it. This graphic I find to be very useful because it shows sort of the whole water management system that is common in the Central Valley, which is, we've relied on snowmelt for 1/3 of our water supply. It holds it till the summer and releases it slowly. Reservoirs along the rim of the valley capture yet another 1/3 of our water supply and hold it there until it's ready, it's needed to distribute through the canal infrastructure out to farms for irrigation. And when snow and reservoirs are not available, we have historically drawn from the groundwater for another 1/3 of our water supply. Unfortunately, when we have droughts and there's less water, or as projected under climate change with less snow melt, we are going to be increasingly relying on groundwater supplies to meet our crop and urban needs. So the only way to stay in balance and keep agricultural in production and avoid depleting our groundwater supply is to capture runoff that's going to occur more as rainfall in the future and less as snow, and capture that. And the primary method that people have used to capture it is dedicated recharge basins, which are quite effective, but do require taking land out of production. So the alternative that we're exploring is the use of farmland for recharge during especially high peak years, when it just doesn't make sense to build enough basins to capture that water. So, by recharging both through basins and farmland, will provide a reliable supply of water during dry years for farmers to stay in production. So the big question under the Sustainable Groundwater Management Act is how much farmland do you need to capture the available runoff that's projected in the future in order to keep groundwater balance kept, or maintain groundwater balance. So we talked with a lot of irrigation districts about what information needs they have. And I oftentimes mention the Stanford survey of irrigation districts also, that ask them, what's the biggest data need you have in order to plan for groundwater management? And what that study showed was the biggest question is they don't know where the best place to do recharge is. And that certainly lines up with one of the first question that we heard, which is where should we be investing, either in basins or farmland recharge? What land should we protect from development and maintain as good recharge land? And then right after that is, especially if we're trying to talk about farmland, is when can the crop take water? And if we optimize those locations, how much total surface water can we actually capture? Can we capture all of it? If we can, how much acres does that take? And what would it cost? And then if we capture it, what percentage of our current groundwater overdraft can be addressed by doing that? So really what the districts were asking for is some way to prioritize their investment decisions. They wanted to know, where should they invest to maximize recharge? And how do you prioritize sites to include in recharge programs like you're hearing about from MID? And throw in any examples you have of stories and what you've heard from districts. Danielle, you have a lot more of that firsthand knowledge now than I do. So build that in. And part of this whole thing is helping these districts design programs and policies to attract the most cost-effective acreage into those programs. And incentives is a big piece of that GSAs are going to be working on in the future. This was funded by both public and private sources. We had the San Joaquin Valley Green Print, which is a part of the Fresno Council of Governments as government source, and Windward Foundation, a private foundation, helped support development of this tool. And although it was designed for Tulare and Madera's needs as a preliminary prototype, it's really been designed to be localized and customized to other locations. This is a schematic of basically the functions that GRAT conducts. It starts by looking at the water that's available to a district based on historic flows and the water rights that the district has to take those waters. The districts define this. The tool then looks at the conveyance network in the district of canals and pipelines and evaluates where water can be delivered and the capacity, the relative capacity of putting water across the district. and this is a key point, is that the canal system is not, the tool doesn't run a engineered sort of hydrologic restriction. It ranks based on the turnout size throughout the district. So if there's a turnout that's only one CFS versus another one, 5 that 5 CFS is going to get a higher ranking than the 1 CFS. So it just says where they've got the capacity to put more water more quickly. The tool then looks at site suitability of each and every parcel in the district down to the individual crop unit, and looks at the soil and underlying geology of each site, and also the depth to groundwater, right? Those fields based on their suitability, and also overlays then the type and the time of year and the amount of water that can be put on that crop, because matching up the water availability across the year with the crop acceptability is key to knowing how much water can be applied on farmland. The tool allows the user to decide between on-farm and fallow fields or dedicated recharge basins, existing ones. So just a side note, we are building in a new function to be able to pick new recharge basin locations as well. And then it calculates, so like based on the
totally new building dedicated basins?
Yeah, exactly. Because we keep hearing that. PID, for instance, doesn't need any more basins. They've already got a lot of basins. Most of their water appears to be able to be caught in those. Madera, on the other hand, it quickly fills up those basins that it has. And they're thinking, what if we were to build another basin? What would be the cost trade-off of building a basin versus, having, 500 acres of farmland or one 50-acre basin? And so the tool will be able to calculate based on the cost of operating farmland versus the cost of operating existing basins, and in the near future, the cost of building new basins and operating them. And that'll be a key question. So the tool gives an output in terms of the dollar per acre foot of water stored for different scenarios the district wants to run, and how that plays out in terms of benefiting groundwater recharge space. You want me to just keep going like this?
Yeah, no, that's perfect.
Okay, because you'll go back through it and pick what you need from it.
Yeah.
Good. Okay. This chart from the Merced River demonstrates the variability of water availability that districts have to contend with. And what this shows in orange is the amount of flows across all these years that the Merced district is able to actually take for recharge during the winter months. And these charts are from November to March. And so typically districts have built these dedicated recharge basins to capture water, but what this chart shows is there's a lot of water that's not captured in most of these wet years. And it's this wet year water that's going to become increasingly critical to capture to offset the pumping of groundwater in dry years. The dark green section of the graph indicates water that the district has the capacity to run through its conveyance, but has no place to put. And the light green is water that goes down the river that existing turnout from the river couldn't even handle. So they'd have to build new infrastructure to capture that. But the dark green could potentially be put on farmland, or new recharge basins could capture that. And what they have to determine is it worth building a dedicated recharge basin for this frequency of water availability, or how many more basins versus should you just use farmland to capture it?
So is that light green, is that also environmental flows or anything like that?
No, all of this is above and beyond environmental flow.
Okay. All right, so just like the GRAT.
Basically, Yeah, so it's like you skim off all the water that needs to go down the river first, then there's this much available.
Okay.
This chart shows that better. This gets at the actual monthly flows that also have to be accommodated. Those last ones were annual. And here, the required minimum flow is in blue, but above and beyond blue is all these green bars flow that was not used by the district. The orange, but was used by the district for irrigation purposes. So that's water that could have been diverted. And we're trying to find crops that could take that water, not just during the dormancies back here when the flows are relatively small, but during these really high flows later in the spring and up into early summer.
Okay. Yeah, because the flow things, people ask a lot of questions about that.
Yeah.
In the meetings where you're presenting, just is this for environmental? Is this supposed to go here? Is it supposed to go there? So.
Yeah.
This is good.
And these are graphs from Merced, or from is this one Merced also? I think so. But each district needs to answer these questions themselves, look at their own data, and that's the data that we put into GRAT. We essentially work with them to look at their historic data and how many years of frequency do they see it on, and also when does that water come on a monthly basis. And we take those historic monthly flows to estimate weekly water availability for each of the different types of rain years, because this is showing water distribution probably in a very wet year.
Yeah.
For this district, it's picking maybe this year here and not a lower flow year. And so we have to build those graphs out from their data and plug that into GRAT. That's part of the cost of GRAT, is incorporating that data.
And I saw San Joaquin River in Merced all this winter, but I still see that photo and I cannot believe it.
Yeah. Yeah, it is pretty amazing. When we get water, we get water.
Yeah.
And it's great for wildlife habitat, luckily in some places, but there's still plenty of it for these other purposes. So this is just an example of how the GRAT, what the underlying data is for GRAT in terms of picking individual sites. We use UC Davis's Soil Agriculture Groundwater Banking Index and combine that with underlying geology in this Land IQ consultant developed recharge suitability index. And I like to tell folks that this is sort of a combination of public data and private data, but our website has this people can look at and dive in detail to see individual field levels. And in cases where they want more detail, it's SAGB plus an index of geologic coarseness. And at some point, we should probably look at these different data layers with you so you can see how these work. But I'll just say quickly that Central Valley hydrologic model takes 50-foot intervals of underlying geology based on well logs that were collected. Whenever anybody drills a well, they have to report what sort of soil textures they went through. And USGS took all of those well logs and on a mile-by-mile grid defined each 50-foot interval as having 50% sand, 20% clay, 30% gravel, whatever it was. They defined that in 50-foot depth. And so it comes down to the more coarse material you have in that 50-foot interval, the more likely water will go through. And so all of those, every state is rated in terms of that coarseness factor.
Okay, yeah,
so,
you were talking about that during the GRA meeting.
Figured those folks would understand that, right?
Yeah.
Other audiences don't need to talk about it.
Yeah.
It also has thickness of clay layers. So I recently saw somebody's response saying, you really don't need thickness of clay if you're using CVH layers. because if there's a thick clay layer, this is going to come up with a low coarseness. There'll be less gravel and sand, so much more clay. There's a whole debate about that. We'll deal with that, work with a broader stakeholder group that refine this index. And then finally, the DWR depth groundwater, which is in GRAT. We can show people that layer. It has the contours of how deep the groundwater is under any given site.
Mm-hmm.
And then that methodology was developed by Land IQ with the Almond Board funding, but it was also modeled on the work of RMC, Water and the Environment, which I always like to give them credit. They came up with the index. Our Land IQ just expanded it to the full state. And then crop compatibility, which really is, the words are all right there, but this really is a key piece of information, and it's based on, it's really trying to evaluate during what weeks do crops have the capacity to receive water in excess of what's being applied for their crop demand. And there's not a lot of research on this. UC Davis has been trying to develop good numbers on alfalfa and almonds, but most crops it's lacking. And for the most part, that work is all focused on dormant winter season crop compatibility. So we've been working with Vachon and Associates to look at extended season recharge, and we've talked with agronomists and growers who've been doing this and asking them how much water they're comfortable for, conservative level, how much water they would apply during different weeks of the year. All of this assumes well soil, which GRAT defines, and right now we've got it for these major crops as well as for fallow land soil characteristics. And we're continuing to update this calendar as new science develop.
Okay, and I asked Lottie this question, and it's kind of a funny question, is we capitalize crop compatibility calendar? Because that's...
Say it again?
We capitalize crop compatibility calendar.
Oh, I see. When we're writing about it someplace?
Yeah, if I'm I was emailing somebody, I was like,
Yeah, I guess so. I guess we do, because it's something we are developing.
Yeah, okay. Yeah. Just sorry, an aside.
Yeah, and so a key thing on that is we don't send out the full crop compatibility calendar to anybody.
Yeah.
But we did that one consolidation down to monthly amounts, and that's the one that we're comfortable sharing with people.
Okay, yeah, I was emailing MID just saying, we want to interview these growers for the crop compatibility calendar. And I realized I didn't know if we capitalize it or not. So. Yeah,
and when you say that, I mean, we know what the crop compatibility calendar is, but so it's probably good to say for the crop compatibility calendar that we are developing, so that they know it's not something they should find. They're not going to find it online someplace. It's not out there.
Okay.
Existing.
Yeah. Okay.
Yeah. And then finally, GRAT looks at the cost per acre of practicing either on-farm recharge or dedicated recharge basins. We conducted the study with some engineering input as well as interviews with farmers and irrigation districts to calculate what the capital expenditures are as well as the annual operating costs for these two different methods. The costs that are shown here are the amortized or annualized cost over 20 years, showing the cost per acre foot of water stored. So the actual cost of doing this work, for instance, on that dedicated recharge basin is in the millions of dollars to build it. But because it can take so much water during a few wet years in a 20-year period, it brings the price down to about $125 an acre foot. Though we've also seen basins that are costing more like $250 per acre foot stored. On on-farm side, the costs are much cheaper on an annual basis. They pretty much are the same as the annualized cost, because at the $40 level, that's just the cost of preparing the field, putting up some berms, and paying the field operator, irrigator, to run the water. If the field requires installation of new flood pipes, like the example you were describing to me earlier, Danielle, the cost can go up because of the purchase of those pipes or renting of those pipes, and potentially additional pumping that might be required, and that pushes up to the higher annualized cost of $107 per acre foot. But if it's strictly gravity fed out of an existing flood control system, it's more likely down in the $40 an acre foot cost. Okay, and that brings us to the GRAT demo part.
Okay.
And we're coming up on 2 o'clock. Do you have time constraints? What do you do?
Yeah, I have a call at 2 about the ABC poster.
Okay. Why don't we pause there?
Okay.
And then resume. Let's find a time that we can do that in the near future. Let's see.
So our next check-in would be the 30th.
Let's see. I guess with the holiday coming, it's probably not. That's not that far off.
Yeah. Yeah. Very true.
Yeah. Unless you have anything come up beforehand, I think that that's probably okay.